Hello everyone, my name is Philip and I welcome you back at the fourth tutorial from the tutorial series called Development of Algorand using Raspberry Pi. Today we will dive a bit into certain aspects regarding monitoring of our health of the node. Then we will dive into the expectations of our monitoring tools which we have, and finally we will try to integrate all of this stuff with Algorand network. So firstly, let's dive into a motivation. So as you might have known, as I mentioned in the previous tutorials, in case your node is not healthy and basically cannot really participate in the consensus, it's important to mark it offline. But now comes the question how to keep an eye if the node is healthy and it's participating. And the motivation basically which we want to cover in this tutorial is to keep an eye on the hardware health of the node, but also keep an eye actually if the node is participating in the consensus mechanism itself. So how can we do the monitoring of the hardware health of our Raspberry Pi? We have quite large family of tools which we can use directly on Linux. So for example, for monitoring of the CPU status, we can use programs like top, iostat or SAR. We can also use to monitor the temperature, so there are of course some hardware dependent solutions, and also Raspberry Pi has own built-in solutions. And for traffic, we can also use tools such as iftop, winstat or bmon. And also regarding checking the health of the RAM, we can use tools like free or top again. But of course these tools work really well, but the important part is how to get notified, or for example how to see this data in real time, and not only that we are collecting them over a certain period of time and later visualizing it. So how to make this data live, which is generated by such great tools which I previously mentioned. And an idea for that is to use some dashboard solution which will be continuously collecting the data from the system and also visualizing them. Such a dashboard solution can be done, for example, using Grafana. So Grafana itself is an open source tool which we will be using in this tutorial, and Grafana itself is web application which is used for visualization of the data which we collect. But of course, having just a tool for visualization is not sufficient, and we need to also have the full chain, which means that we are actually collecting the data from the system, we are storing them in some database, and later on actually we can visualize them. And for the storing of the data, we will be using InfluxDB. And for collection of the data sources from the system, we'll be using the Telegraf, which is basically a daemon which is running on our Raspberry Pi and is collecting the various metrics which we wanted to collect. And finally, since Grafana is an open source solution, there are a lot of available open source monitoring dashboards, and specifically this one is aimed for Raspberry Pi, and it has the ID 10, 57 and 8, and this is basically the Raspberry Pi health monitoring solutions which we will be using for the tutorial. And covering the steps of the tutorial, we will of course firstly need to install this required tool on the Raspberry Pi. We will also have to modify the configuration files, and finally we will add the dashboard for the Raspberry Pi monitoring tool. But this is only covering the check of the hardware status and the hardware health of our Raspberry Pi. And in the second part of the tutorial, we will cover the aspects of keeping an eye on the node and its participation in the Algorand network, where fortunately Algorand is already offering a solution for that, which is called metrica.io, and we will show what type of subscription we can do and how can we connect to this metrica.io solutions, which is mostly focused on the node participation in the Algorand network itself. So without further ado, let's have a look on the initial steps, how to install the required tools for the visualization of the hardware monitoring, connect it to and modify the configuration files, and finally have a look on actually how the dashboard looks like. So in the first step, it's important to install the required packages, where we can start with the installation of the Grafana. I already have done these steps before, so I will not repeat them, but I will guide you through the steps individually and explain what it means. So since Grafana itself is not part of the common Debian repositories, it's also important to include the specific package manager or the specific repository for Grafana. So for that we will add the Grafana repository to the list of our repositories, and for that we need to firstly add the public key of the Grafana, so actually we are able to identify it, and later on we add the repository itself to the list of our repositories, and with that we will be able to install it to our system And in order to make the Grafana boot after the Raspberry Pi is restarted and so on, we have to configure the systemctl to make sure that the system is enabled and can start after this system. And with that, our Grafana is basically installed. We can also have a brief look how this looks like. So once you reach this stage, you will basically, you can navigate to the IP address of your Raspberry. Since I'm currently doing this I'm connected to the Raspberry Pi over SSH, where I would execute the steps. And in case I want to connect to the Grafana, I have to know the Raspberry Pi IP. And since I'm sitting basically in the same network, I can just easily navigate and put the IP to the browser of my local machine with the port 3000, and I can enter the Grafana tool. And in the first place, of course, I need to sign in, so the default password is not something challenging. It's basically admin. So of course you are recommended to change it as soon as possible, which I have not done yet. Now you see that the Grafana is functional and you have all the available options, which I will be showing later on. But having Grafana on its own is of course great, but we currently don't have really any possibilities how to visualize the data and so on until we fulfill the next steps, where the next big step is to install the InfluxDB and the Telegraf. Similar story like we had done for the Grafana. We have to again add the corresponding repository to our system, so we can later on install InfluxDB and Telegraf. And again, in order to make sure that the services are running after we reboot the system, we have to also enable them. And now basically with that, we have installed all the required dependencies. So this means that we have the Grafana tool for the visualization, we have the service which is collecting the corresponding metrics from the system, and we also have a database in which we can store the required information. So now the next part is how to configure all of these pieces to work together. So in the first place, we would have to navigate to the Telegraf configuration, which is something what we can do. And now we need to be locally on the Raspberry, and we would navigate to the, with sudo, we would navigate to the place where is stored the configuration of the Grafana. In here we would specify the port on which is the Grafana running. So here we specify this port, and it's currently looking on the local host, because basically this is something what we don't have to necessarily have publicly available, because this is important that the Grafana actually knows how to access this database. We can specify the database name, and we can also specify the username and the password, which currently I have chosen the username Telegraf and the password metrics123, and of course this is something what you can change. And after you do all of these changes, save it actually in your case with, and that way you can proceed to the next part. And in order to the changes to take place, you have to make sure that the service is restarted, for which you can use the following command, and with that these changes will be taken into account for the future. And now we can already navigate to the Grafana, and we can add this corresponding database to our system. So how do we do it? We would go back to our Grafana tool, and here we would navigate to the configuration, and here we can pick the data sources. As you can see, I already have done it before, but for you would basically click on the add sources. Here you would see InfluxDB. You see the data sources added. Here you can specify the URL, which is something what we have already done before. You can choose the name. So this name doesn't have to match with the previous one, so you can choose it, for example, you can call it RPI2 or whatever you prefer. And here are the important parts. So these fields have to match with the fields which you mention in the configuration file. And with that, I will just hit save and test, and the database will be added to my system. So I can quickly show you how this is. I will delete the temporary solution, but basically I can show you how is it done for the previous one. You can of course always come back and try to modify it. So here you can see the database name, you can see the user and the password which is configured. So with that, we already now have the database which is storing the information, which is an important step. We want to combine the data which we have, but then we want to start to visualize them. And in Grafana we can do it by navigate to the manage, and here we can go to the import part where we want to specify which dashboard we want to use for the visualization. And you can do it by various ways, but the easiest way is to do it by the ID name, which, as I was mentioning, our dashboard has this following ID. I will provide also the link to it later on, and as you can see already, this is something which I have already selected, and therefore I cannot really do it, but for you this should not be the case, so you can easily do it. So after adding this step and adding the dashboard, we are still missing one piece. So basically the last piece which we are missing is this corresponding configuration, which is specific to the corresponding dashboard which is imported. So to finish this part, you can even try it. You can navigate to the generated dashboard, but you will see that actually it does not have any data. And how to ensure that the data will be visible is that we have to again navigate to the configuration of the Raspberry and copy and modify the configuration. So I already have done it. So as you can see here, I copied here this configuration. So it's basically looking for the statistics. It's also looking for the file to basically collect the temperature of the CPU and also the GPU temperature, and it will of course also collect or other parameters which don't have to be necessarily specified here, because these are common matrices which are already not unique to this dashboard, because this is specifically customized for the needs of the Raspberry, especially the temperature parts, but all the other parts are already available by default from other dashboards and are not Raspberry specific. And after you do this piece, so now you also have configured the specific configuration of the dashboard, you can navigate to the final part, which is basically having a look on your Raspberry dashboard, which is something what we can do now. And here you can see the various metrics. Very important one is of course like your uptime of the node. So in case there will be, for example, some restart in the middle, you would actually see that the uptime is rather short. And you can also see the CPU usage, which is actually a really nice metric to see. For example, depending on how the network is busy and so on, you see that there is more work for the Raspberry to, for example, validate larger number of blocks, which can be caused by different stuff, or the blocks have larger number of transactions which have to be verified. And you can also see the memory itself, how busy is the Raspberry Pi with handling this load, and you can see many other details. But also really nice, I think, to look into is the network usage. So what is the required uplink and downlink, where we see that currently it's really small. So now I have a node running and we see that there is rather few stuff happenings. And next part which we can have a look at is also the disk IO, meaning in case there is some storage, and to identify where are the bottlenecks of our storage. And to note, in case you want to see the GPU temperature as well of the Raspberry Pi, you will have to reboot it once so the changes actually take effect, and later on you will see the GPU temperature as well. This is pretty much the shape how it's gonna look like after you do all the configuration, where you will see the NA for the GPU data missing. So after you reboot it, you will actually see it. And with that, we basically finished the first part of the tutorial, where we install the required tools, we configure them, and now we have a really cool dashboard to be able to monitor our Raspberry Pi health status. And in the second part, we will navigate to connect our node to the appmetrica.io, which is a really cool tool to keep an eye and monitor our tools. So I already have done it as well. So you will have to at the beginning sign in using your Gmail account or your GitHub account, and then you will just see pretty much this page where you can later on click on create subscription. So I will just see I will just show you how it looks like. Here you will specify your public key, or basically the address of your node. You can also use some alias in case you have multiple nodes, and you can subscribe to specific features. Where for us it's very important, if we have a node, if it's actually participating in the consensus itself, we want to maybe also have an eye if there are some large transactions happening with our node without actually our knowing, which maybe is important, but I'm not sure how many of you are receiving 250k algos or more. And especially for the node, as mentioned in the previous tutorial, it's really important to keep an eye on the key expiration. And in general, we can also subscribe for any of the other solutions, other information. And after you specify, you will basically create an account like this, where you currently keep an eye on the status, the key, the soft votes, and you can also see to which part is the node subscribed. The really cool part, you will also get the notifications about each of the stuff. So of course you can modify it by muting it, but in case, for example, your key is about to expire, you will get a push notification, and you can see that there are some steps needed, and you, for example, have to create a new participation key so the node can be again participating in the consensus mechanism, and it will try to make your life easier, that you don't have to check it by yourself, but you can use such a cool solution offered by Metrica.io, which was co-created together with Algorand itself. So now when we have set up the dashboard tool, not only for the monitoring of the health, but to monitor the node activity in the Algorand network, we are basically done. And to summarize, in this tutorial we have learned how to set up a health monitoring tool on the Raspberry Pi using Grafana, InfluxDB and Telegraf. We also evaluated which metrics are essential to check the health of the node. So especially you have to keep an eye on the temperature, you have to keep an eye on how busy is your CPU, you have to keep an eye on the RAM, and of course the IO, in case there is something more happening. You are basically able to easily identify also the bottlenecks in your system. And finally, it's important to keep an eye on the networking. If there is more activity than you expect, it can mean that something is wrong with the node. Maybe it's downloading some stuff, or there is currently something happening in the network which is worthwhile to look at. And second part of monitoring of our Raspberry is how basically Raspberry behaves in the Algorand network, and for that we can use the offer tool from appmetrica.co, where we connect our node using our corresponding public key, and we can subscribe for different notifications. Where for us, since we want to have a participation node, is the essential one to see if our participation key is valid, which will make our life easier and ensure that our node is healthy and can easily participate in the Algorand network. And with that, I would like to conclude, and feel free to reach out in case you have any questions.